The puzzle I want to look at today reads as follows. Arrange the numbers 1 through 9 into 3 rows and 3 columns so that the 3-digit number across the middle row is twice that of the top row, and the 3-digit number in the bottom row will be 3 times the number in the top row. So if we look at this, we could say 123 across the top row, 4, 5, and 6 on the next row, and 7, 8, and 9 in the bottom row. So we've only met the first condition of using the numbers 1 through 9 in our columns and rows, but this is just to give you an idea of the setup. So that would essentially mean, 1 in the top column and first row, 2 in the top column and the second row, second column, top row, 3 in the third column, top row, is essentially represents the number 123. And so if we look at that and we say, okay, well, does that meet the next criteria? 123 times 2 is 246, which is a problem because that's not equal to our next row, which is 4, 5, and 6. So this configuration is already not going to be valid to meet our other conditions of this being twice the first row and the bottom being 3 times the top row. But what I want to do is look at this in such a way programmatically. And so to do this, I'm just going to assign variables to the different positions of this. So 1, 2, and 3, I'm going to call A, B, and C. Variables being we don't know what they're going to be, but we'll write a program to test out those values. 4, 5, and 6 we're just going to call D, E, and F. 7, 8, and 9 will be G, H, and I. And so I'm kind of going to use a brute force method, maybe not the most efficient, but to kind of go through all the combinations that are possible and find all the numbers that would fit our criteria here. So first we'll break down and look at what each variable is going to represent. So if we look at A, B, and C, the numbers we insert there, C is just going to be that, first column. If you remember decimal mathematics, it's going to be itself. The second column, the B column here, is going to represents 10 times whatever the digit B actually is. And then the hundreds place is represented by A. So when the actual value, 100 times A plus 10 times B plus C is going to give us our value for the first row. And that'll let us go through different combinations of A, B, and C to represent different numbers. The next row, of course, D, E, and F is going to be, again, the hundreds place, the tens place, and the ones place. And we're going to compare that back to the first row. And so we want it to be twice the first row. So if we multiply each of these times 2, we're going to be comparing it to 200 times A, 20 times B, and 2 times C. And that would be 100 times D plus 10 times E plus F. Okay, just like we did this for the first row. But this is our comparison of twice the first row to the next row. And then, of course, 3 times the first row equal to the third row. So we'll have to write a program to essentially come up with a solution that fits those variables and meets all this criteria. Okay, so let's look at some code here. And just kind of quick and dirty, I'll go up here, and what I'm going to do is just create a for loop for the first variable, if you remember the column A. So I'm going to set up an integer called A, and we're going to go from A being equal to 1. Remember, there were no zeros. It said 1 through 9, so we'll start at 1. And we'll go through all the combinations of A up to less than or equal to 9. And we'll get there by 1, so we can just do A plus plus to increment. And so we have our for loop that's going to go from the values 1 through 9. Okay, and then we need to output that so we can see what it is. So I'll output A, inline, and so that's just going to output 1 through 9. So let's execute that just to see that we got our for loop set up right. So, and it pops up with all the values 1 through 9. So that worked out okay. So the next thing I want to do is add a nested loop. So I'm going to move down here. I'm going to add another for loop for our next digit. And of course that's going to be B. And we want to run through the same combination. So B equals 1. And we're going to stop it at 9 as well, less than or equal to 9. And do B++. And then align our for loop here so we have that. Let's change our output so we can add B in. So we have A and B, and so this should run through all the combinations of A and B. So let's compile and run that, and that pops up with all the different combinations of, if I scroll up here, 1 1 1 2 1 3. So we already see there's probably going to be a problem where we have duplicate digits. Okay, so we're supposed to rearrange the digits. So this last one, 9 9, is kind of not a valid number here, but we'll deal with that later. The important thing is we kind of see the pattern, and we do get every combination of digits at this point. Okay, so let's add one more time. We'll go in here and add another for loop for C, and I'll move that over, and we'll add the output for C, and so that should give us that deals our first row. So we should get every combination for the first row of A, B, and C. And let me execute and run that. And that takes a little bit longer, but you can see we've got the first row combinations all the way up to 999. Again, we don't want duplicate values, but we'll take care of that a little bit later. So now we just need to add our next row, but we still want all the combinations. So I'm going to add another for loop, and I'm just going to go D, and we'll do the same thing, D 1 through 9, D++, same thing for E, F, and we need to add a row for this, so we'll do C out D with a space, E, and F. So we've got our second row. Now we'll add some for loops for the last row for G, H, and lastly I, and we'll add our output statements for G, H, and I. Okay, so this should output our rows. Basically our kind of a matrix, that style, that tic-tac-toe style look, except for I just have spaces in between each one. So that goes through every combination. Now we need to start looking at what our solutions are to find valid solutions to our problem. Right now I just set up the brute force, so it goes through every combination. So what we want to do, let me go ahead and add the braces for all these for loops. So you see the nesting is kind of extreme in this case. I'm just going to go ahead and add the open and close brace for each of the for loops. I don't know if that might make it a little less clear, but each for loop doesn't necessarily need these braces, but I'll go ahead and add those in. I want to add the counter because I want to know how many solutions are actually possible. So I'm going to create a variable called solution count, or SOL count, and I'm going to set that equal to 0. So assuming there's no solutions, and inside my inner loop I'm going to have the solution count increment. So if I get here, I want that to be a solution, and then at the end I'll see out there were, and take that solution count variable, that many different solutions. Okay, and now I need to look at actually getting the solution, because right now it's just going to go through every combination. So it's actually going to be what, the factorial of the number of digits we have here. Probably not good to run this. It'll take a while. So I'm just going to go ahead and add our conditions that we need to put in to start checking to see what's valid here. So remember, if we had a condition of 200, so the first row times 200 is going to be the second row. So 200 times A, the hundreds column of the top row, plus 20 times B, the tens column of the top row, plus C by itself, okay, or 2 times C, that's going to be equal to the second row. So we'll just have 100 times the hundreds column of the second row is D, plus 10 times the tens column of the second row is going to be E, plus just the ones column is F. Okay, so if we have that condition, all we're saying is, I could put a comment statement in here saying the second row is twice that of the first row, okay, for A, B, C, D, E, and F. Okay, now we need to check the third row. Okay, and so I'm going to add another if statement. We've got, so inside all of our nested fors, we've got this nested if, and I'm going to do the same thing, 300 times the hundreds column in the first row, plus 30 times B, plus 3 times C, and that should be equal to just essentially the third row. So that's going to be 100 times the hundreds column is G, plus 10 times H, plus I by itself, the ones column in the bottom row. Okay, so that takes care of sort of our solutions, except for we don't take into account for duplicates. So remember, when we were running the test runs earlier, we got 99 in there. We don't want duplicate digits. So we're going to have to deal with that. So I'm going to put an if statement in here. And what I'm going to basically say is I don't want A to be equal to B. So if A is not equal to B, that's a possible solution, but we also need to check A against all the other digits to make sure there's no duplicates. So we could use the logical AND operator, that's ampersand, ampersand, and make sure A is not equal to C, and so on and so on. So we need to check against A not equal to D, and E and F and G and H. So starting to be kind of a kludgy solution, but I'm going to keep going with this. And so on the next one, we need another nested if. And so I'll move this down and we'll put our if statement in there. We already know A is not equal to B, so now we need to check B to make sure it's not equal to C, and B is not equal to D, and so on down the line, all the way to B not equal to I. So we'll continue this nesting pattern, and I'll have next C not equal to D, and so each time we nest the ifs, we don't have to check as many because we already checked C against B and C against A previously. So we just need to check C against D, E, F, G, and so I'll do this again for D, E, F, G, and lastly H not equal to I. And if we get that and we don't have any duplicates, we'll have our solution count will increment, and we'll print out our matrix for one solution. So a little bit unwieldy, and there's probably a couple of better ways to do this. Let's compile and run this and see what we get. Okay, so it took about a little over a second, 1.74 seconds here, to come up with 4 solutions, and it did look like it got rid of all our duplicates. So if we look at these solutions, 192, if we double that, we get 384. If we take 192 and triple it, we get 576. So it meets those two conditions. Looks like it uses all the digits 1 through 9. So this looks like a valid solution. So it looks like we get 4 different possible solutions from this problem. Okay, so let's go back and look at my nested ifs here. This just looks ugly, so instead of doing all that, I'm going to get rid of that, and instead of doing the ifs to make sure they're the same, just a little different way of approaching this, a little bit more mathematical way. I'm going to take A plus B plus C plus D, E, F, G, H, I, and if we add the digits 1 through 9 up, that should be equal to 45. Okay, now this alone is not going to get me a solution because there's different ways of adding A through I together, or the digits 1 through 9. In other words, we could get duplicate 8s without a 9 and duplicates of other numbers that would add up to 45 still without there being unique numbers. So what I want to do is set another condition in here, and I'll do that with a logical and what I want to do is take A, and this time I'm going to do times B times C and all the way through I, and if that's equal to this number, then I'm pretty sure, and again I've got this number by multiplying the numbers 1 through 9 together to get this, so I may get some numbers here that add up to 45 with duplicates, but probably not also multiplying to this number, right? So I'm pretty confident that the addition and multiplication of those numbers together means one of these numbers in each of these cases is going to be the digits 1 through 9 with no duplicates, and it shortens up my code a little bit, makes it look a little bit neater. So I kind of like this solution better. Let's make sure it works though. So I'll do execute, compile, and run. And in a similar amount of time, 1.7 seconds, I get 4 solutions. Looks like the same solutions we had before. So this is essentially doing the same thing as all those nested, comparing each digit to make sure it's not equal to another digit. Just a little bit nicer way, in my opinion, to check for that and make sure we have the digits 1 through 9 in the variables A through I. So hopefully this was a fun problem and gives you kind of an idea of, you know, some solutions to problems like this using a computer may not be the way you would do it by hand because the time it takes to go through every combination, but this is what computers are good at. So hopefully this was helpful and gives you some ideas on future programs you may write. In the future we can also look at a couple of different solutions to this same problem. With programming, there's usually more than one solution to a problem, many more than one solution. So we might look at this again in the future. So I'll see you next time.